So beside this reflecting in the axes, you can add these additional notes for y equals f of negative x and y equals negative f of x. And now we're going to go to example 1. So here we've just got a random graph, and they say that that graph is g of x. And we want to sketch the image after reflection in the y-axis. So one of the things about these reflections is they can ask the same question with a bunch of different words. Here they've said it's a reflection in the y-axis. So what that means is things are going to get reflected over the y-axis. Which coordinates are changing? If you thought of a single point from there to there, is it the x value that changes, or is it the y value that changes? It's going to be the x value. So you know that this reflection in the y-axis is the same thing as y equals f of negative x. So sometimes we have to take the time to interpret what it is that the question's asking and what it relates to. Another way that this question could be asked is they could say, instead of reflection in the y-axis, it could say reflection over the line x equals 0. Because the line x equals 0 is another name for the y-axis. But you have to be able to interpret all of those different ways of asking the same thing. So all we're going to do is we're going to multiply each of our x coordinates by -1. So if we think about a point that we have right here, and we think about the coordinates of that point, it's at -3, 1. If you multiplied that x coordinate by a -1, it's going to flip over the y-axis and go to 3, 1. Can you see that this second point here is going to flip over the y-axis and go there? The third point would flip over to there. And this point over here at 5, 2, when you multiply that x coordinate by a negative, would go over to -5, 2. And when I connect these lines, does it look like the red graph has been flipped over the y-axis? State the domain and range of each function. So now we're going to look for some patterns. What happens to the domain? What happens to the range for both the original function and the image function? Last time I used set notation. This time I'm going to use interval notation. So for our domain and interval notation, we looked for our smallest x value. It's at -3. Our largest x value is at 5. So our x values go from -3 to 5. Our smallest y value is at -2. Our largest y value is at +2 for our original graph. Now, when we look at our domain and range for our blue graph, we'll notice something. We'll notice that the range is the same, but the domain has changed. How has the domain changed? Well, when we reflected over the y-axis, that was something that had a negative inside the function, which only affected the x values. So it would make sense that only your domain gets affected, and our range stays the same. And if you look at your domain, can you see that those values have been multiplied by a -1? Instead of going from -3 to 5, now we're going from -5 to 3. Sometimes you're going to get questions that are out of context. I could give you just the domain. I say the domain of a graph goes from -3 to 5. That graph is flipped over the y-axis. What is the new domain? And so you only have this bit of information to go from here to here. In those cases, sometimes it's helpful, make up a graph. And you can draw it out to see what it would look like. Sometimes that's helpful. Or maybe you can understand, oh, that's just affecting my x values by multiplying by a -1, and that is what would happen. Okay, try 3 and 13.